Hey, what's up guys? Today we're going to be doing AP Calc AB Unit 3 review, differentiation of composite, implicit, and inverse functions. We're going to be starting off with the chain rule. If f and g are both differentiable, then f at x is the composite function defined by f at x, f at g of x. Then f is differential by f prime and is given by the product of the derivative of f of x multiplied by g of x times the derivative of g of x. So what does that look like? Well, if we take the function, for example, x squared minus x plus 2 to the fourth power, and we take the derivative of this function, right? Then we take the derivative of the outer function, which in this instance would be this exponent. So basic rules here for x squared minus x plus 2, subtract 1 off the exponent, 3. So multiply by the front, subtract 1 off the exponent, then you find the derivative of g of x, which in this instance is the interior function, and you multiply it by what you just found. So 2x, bring down this, the front, subtract 1. Derivative of negative x is just minus 1, and the derivative of any constant is 0, so this would be our answer right here. So that is the chain rule in a nutshell. Okay, so now I'll do a few more examples for you guys, and then I'll move on to the next topic. So let's take the derivative of the square root of 7x minus 2. So how do you think we should start this, guys? Well, I would turn that square root into an exponent so we can apply our rules to it. So we have 7x minus 2 power over root. In this instance, the function is being raised to the first power, and the root is 2, so we have to 1/2 power. Now we can take the derivative of that function. So multiply the exponent by the number in front, which is 1, so 1/2 times g of x, which is the function inside, and then you subtract 1. 1 minus 1/2 is negative 1/2. Multiply by the derivative of g of x. In this instance, the derivative of g of x is 7, because the derivative of any constant is 0, and 7 of x, 1 minus 1 is 1, x to the 0 power is 1, so 7 times 1. So it's just 7. So this would be our answer for the derivative of the square root of 7x minus 2. Okay, moving on. We'll do a trig one for you guys real quick. So the derivative of sine of pi over 2 minus x. Well, in this instance, the outer function is sine, the inner function is pi over 2 minus x, so we find the derivative of the outer function times the inner function. Derivative of sine is cosine. And we multiply it by the inner function, and then we multiply that by the derivative of the inner function, which is negative 1. Derivative of any constant is 0. Derivative of negative x is negative 1. This would be our answer. Now we'll move on to implicit. Okay, so before we move on, I want to quickly review this table. So you should have these memorized. Derivative of sine is equal to cosine x. Derivative of cosine x is equal to negative sine. Derivative of tan x is equal to secant squared of x. Derivative of cosecant of x is equal to negative cosecant of x times cotangent of x. secant of x equal to secant of x times tan of x, and cotangent of x is equal to negative cosecant squared of x. So the way I like to remember it is the c's are negative, and that's just a little useful trick for you to remember, that if the derivative of a function that's of the trigonometric function that has a c in it is always negative, and if it doesn't have a c, then it's positive. Okay, moving on to implicit differentiation. Okay, moving on to implicit differentiation. So the difference between implicit and explicit differentiation. So in explicit differentiation, the function can be expressed as an equation in terms of one variable. So it's y equals or x equals, and the function only contains variables of one type. So another example would be x squared plus 2 or y squared minus 4. An implicit function, the function is implied by an equation. You can't separate the variables. So it's difficult to express y in terms of x. So in this case, you'll see a bunch of variables on the same side of the equation, not separated. That's what we call implicit differentiation, and we're going to talk about the rules for what happens when you're trying to find the derivative of a function like this. Okay. So when you're doing implicit differentiation, you got to keep all the old rules that you learned in your mind. So I guess we're just going to run through some problems. I think that's the best way to explain to you how this works. So we're going to start off with the function x squared plus y squared minus 9 equals 0. So if we were going to find the derivative of this, we would just apply the rules we've been learning about all this time. So derivative of x squared is 2x, 2 minus 1 is 1, so x to the first power, plus apply the rule to y squared, 2y, then you have to multiply it by the derivative of y, and the derivative of y in this instance is dy over dx. Derivative of a constant is 0. So then subtract 2x on this side. 2y dy dx equals negative 2x divided by 2y. We get dy dx equals negative x over y. Okay. You express whenever you can't find whenever you're searching for the derivative of y, you can't express y. You can't find the derivative of y, so you just express it as dy over dx. So moving on, here's another example: x squared minus 2xy plus 3y squared equals 2. So find dy dx. So 2x minus 2 times, so the derivative of xy would be just apply the product rule to x and y. So x times the derivative of y, which would be dy dx, plus y times the derivative of x, which is just 1, plus 6y dy dx equals 0. Then you just simplify that a little bit. Dy dx times 6y minus 2x equals 2y minus 2x. So dy over dx equals y minus x, 3y minus x. And before I hand you over, I thought I'd just show you this formulas and theorems sheet, which might be helpful. So if you wanted to save this, then it might be useful as a refresher as you go along Unit 3 in your school.
Okay, now let's move on to some derivatives of inverse functions and inverse trig functions. So let's start off with a quick recap of what inverse functions are. Here we have a graph, here's the original function, and here we have the inverse function. A quick thing to note about inverse functions is that they're reflected over the y equals x line. Okay, so if g of x is the inverse to f of x, these two things have to be true. So there's a point on AB, there's a point AB on f of x, and there's a point BA on g of x. Now this seems a bit confusing, but I simplified it here. It pretty much means that x and y interchange for inverse functions. So in this case, we have this point right here, which is 1 comma 0. And on the inverse function, we have the point, but the x's and y's are switched. So right here, we have 0 comma 1. Okay, so the College Board wants you to be familiar with this right here. It states that f of g of x is equal to x, which is equal to g of f of x. So you don't need to prove this in any way, but you do need to understand that this composite function is equal to this composite function, and they're both equal to x. Okay, so now let's move on to the calculus portion of this topic. And let's start off with, let me zoom in real quick. Okay, so let's start off with this question right here, which might show up on the AP exam or one like it. So let's say we have a function f of x equals x cubed. So they're asking for what is the derivative of the inverse of that function at 8. Okay, so the first thing I want you to look at when looking at this problem is right here. So it's asking for the derivative of the inverse at x equals 8. So by asking this, what it's actually telling us is that there is a point on the inverse function of x where the x value of that point is 8. Okay, so let's say that on this function we have that point where x equals 8. Now we don't know what y is yet, but we'll get to that. And because we're talking about the inverse of f of x, we also know that on the function f of x, we have a point where y is equal to 8, because all you have to do in order to get an inverse function is swap the x's and y's. So from this right here, we were able to deduce that there's a point on the inverse function where x is equal to 8, and there was a point on the original function where y is equal to 8. Okay, so we don't know what the x value, or what this value and this value are yet, but that's what we're going to do next. So for step 2, let's first look at the original function. So if you remember all the way back to early algebra, you'll remember that we used to call this y. I mean, f of x and y are interchangeable, essentially. So we actually have the y value for this point. So if we call this y, we can just plug y right back in, right? So that would make 8 equal to x cubed. So essentially what we're trying to do here is we're trying to find the x value. So all you have to do is some simple algebra. You find out that x is equal to 2. Okay, so now we can plug that back in. We have this point right here. We also know that for the point on the inverse function, that y is equal to 2 because, like I said before, you just have to swap them. So once we filled it in, we have these 2 points. This is very important in order to solve the rest of this problem. So in order to understand the next step we have, we first have to understand this right here. This is crucial to understanding how the derivative of inverse trig functions work. This right here states that the derivative of the inverse of f of x is equal to 1 over the derivative of f of y. Now, technically, this right here, this is the derivative of f of x. However, I just swapped out the composite function f of x for y just to make it simpler for this problem, and you'll see why. Okay, so let's move on to this next step in which we pretty much just plug in everything we have. Here we have the derivative of the inverse of f of 8 is equal to 1 over the derivative of f of 2. Okay, so we put this 2 here from the y value of the point on the inverse function. A quick check to see if you're on the right path with this problem is you should have the x value here and the y value here of the point of the inverse function. So pretty much you don't want to have two of the same number. You don't want to have an 8 here and an 8 here, or a 2 here or a 2 here. You want to make sure you want to have one x value and one y value, the x value being here, the y value being here of this point right here, right? Okay, so once you've established this, now you are trying to solve for the derivative of f at 2. Okay, so that's pretty simple. Sorry about that. So yeah, it's pretty simple. You just want to differentiate this function. You get 3x squared, and then once you are trying to find the derivative at this point 2, you'll get 12 because you just plug in 2 and you get 12. So then you plug in this this result right here. You plug it back into this function here, and that's how you get 1 over 12. So essentially, it asked us for the inverse, or sorry, the derivative of the inverse of f of x at 8, and this is that result. So let's move on to another problem on this topic. So for this problem, we have f of 5 is equal to 20, f of 7 is equal to 5, f prime of 5 is equal to negative 4, and f prime of 7 is equal to negative 5 halves, right? And here it's just saying that g of x is equal to the inverse of f of x. So pretty much g of x and f of x are differentiable functions. So it's asking for the derivative of g of 5, right? So we have all these points here, so let's write them down. You have f of x, x values being these right here, of course, and the y values being those that correspond on the opposite side of the equation. So we have 5, 20, 7, 5, and we know that g of x is the inverse of f of x. And what we know about inverse functions, like I mentioned before, is all you have to do is swap the x's and y's. So this is 2 points on g of x, right? So all we did here was swap the x's and y's. We got 20, 5, 5, 7. Okay, so what you want to do first is remember we talked about this equation, or yeah, right here. So let's actually use that. So we have this is the same thing in this circumstance because g is the inverse of f of x as g of x, right? Or yeah, g of x. So the derivative of g of 5 is equal to 1 over the derivative of f of 7. And as you can see, quick check, we have two different values right here. We don't want 2 5s or 2 7s. That wouldn't be good. So moving on to step 2, we plug in for this right here, right? The derivative of f of 7. So what's the derivative of f of 7? Well, they told us in the problem that the derivative of f of 7 is negative 5 halves. So you really don't have to do much work here, which is really good for you because you get the answer right here, right? So you plug this in for this, you get 1 over negative 5 halves. You simplify a bit, you get negative 2/5. Okay, so now let's move on to some derivatives of inverse trig functions. So Ryan talked about this a little bit prior to me talking about it. So this, sorry, these are pretty much what you have to use to find the derivative of the inverse trig functions, of course. So these are the equations corresponding to each trig function. So you don't have to prove this in any way. They do prove it on AP Classroom, but you don't. The AP test, you're probably going to see sine and cosine the most, even some tangent, but secant, cosecant, and cotangent rarely show up on the AP test. All right, so these are pretty simple. Let's jump right into a problem. So right here, they're asking for the derivative of the inverse tangent of x cubed, right? So let's figure that out. So let's go back to our, 1 second. Let's go back right here. And this explains the derivatives of inverse trig functions. So right here we have the inverse tangent, right? So let's go right here. You should memorize at least sine, cosine, and tangent, but you'll get the hang of it over time. So right now we'll just use this little chart right here. So we have the inverse tangent, and this is the equation we should use for that, right? So it's asking for u prime over 1 plus u squared. So let's go back here. So essentially, u in the circumstance will replace with x, right? So the first thing I want you to do with these types of problems is I want you to identify what u is. So u in this circumstance is x cubed, right? Um, and then right after that, I want you to identify the derivative of this right here. So the derivative of that is, of course, 3x squared, right? And then I also want you to identify u squared. So that would be this right here squared, right? So be careful with this. It's not x to the 5th. You're not adding because because this is raised to a power. You'd actually be multiplying the exponents, so it would be x to the 6th. Okay, and the reason why I want you to identify 3 of these because we're going to be using the derivative of u and u squared in order to find the derivative of the inverse trig function, right? Okay, so all you have to do right here is plug in. So, all right, I was trying to see if we could do it side by side, but we can't, but that's fine. So, let's figure this out. So the derivative at x cubed, I'm not sure if this is proper notation, but you get the idea, is equal to 3x squared, because that's u squared, right? That's the derivative of u, right? So we have 3x squared over 1 plus x to the 6th, that being u squared. So all you have to do pretty much is identify these 3 things, these 2 things more so, and then just plug it into the equation, and you should get this as your result. Pretty simple, right? Okay, I'll give you 1 second to, or a few seconds to look over this problem right here. So it's asking for the derivative of the inverse cosine of 3x is equal to ln y, right? So to start off, let's try to get y prime on one side. So let's use some implicit differentiation, right? So let's first start off with raising both sides to the power of e because we're trying to get y by itself. So let's raise both sides to the power of e. By doing that, you'll get rid of this ln right here, right? So once we got rid of that ln, you're left with y is equal to e raised to the power of inverse cosine of 3x. This is also another notation of inverse cosine. These two mean the same thing, arc cosine and inverse cosine, right? Okay, so now let's start with the implicit differentiation. We have right here, y prime is equal to e to the power of inverse cosine of 3x times, now you have to make sure you include this right here because as you can see right here, we're using chain rule, right? So in this circumstance, in order to differentiate this portion right here, you have to do the entire function, or the entire function, and then you also have to do this small one contained within it, right? And that's how you apply chain rule. So what's the inverse cosine of 3x? Well, that's pretty simple because we just learned it, right? So let's go back. Oh, we have it right here. Never mind. So first we identify. I didn't do it in this circumstance because it's fairly simple, but you can if you want. Identify u prime, and u squared. Here we have 3x, right? So that's our u. U prime would just be 3, and then u squared would be 9x squared, right? So we just plug in. So once we plug in, we have 3 over the square root of 1 minus 9x squared. Okay, so now we just have to simplify. So bring this up top, multiply by the 3 because we can multiply, so we can group them together. So we have negative 3e raised to the power of the inverse cosine of 3x. So that's how you solve that problem. Oh, and I also forgot to mention here, I made an error. This should be a negative 3 because this is just u prime, right? But it's asking for negative u prime. So we just applied the negative. That's where you get this right here. So if you were confused, that was an error on my part. Okay, so we have our last problem here. This is asking for the derivative of the inverse cotangent of the cosine of x. So this might seem like a really confusing problem, but don't worry, it's quite simple. So let's first identify these three things. So we have u is equal to cosine x, right? What is u prime? Well, u prime is the negative sine x, and then u squared is cosine squared of x, right? So we look back at this equation right here, and all we have to do is plug in. So let's start with up top. So we have negative u prime. Well, u prime is negative sine, so the negative of negative sine is just the positive of sine, so we have sine x up top. And then that's all over 1 plus u squared, and that's pretty simple. All it is 1 plus u squared being cosine squared x, so it's 1 plus cosine squared x. So the final result being sine x over 1 plus cosine squared x. And that's that for derivatives of inverse functions and inverse trig functions.